let's discuss question number 48 and 49, which is a common data question. This is from test 11, theory of machine. Okay, so in a spring mass system, the following data is given. The mass is 2.5 kg and the spring constant is 3 Newton per mm. The amplitude decreases to 0.25 after of the initial value. So the initial amplitude is x0 and after 5 it's basically 0.25. so this is after 5 cycles. Okay, and what is asked is the successive decrement. Okay, so one thing which you have to remember is that in a spring mass system, okay, when it's a case of undamped vibration, one of the important result is that, like when you plot the amplitude versus the time, okay, it tries to decreases, the amplitude goes on decreasing, but the ratio at which it decreases, let's call the initial being h0 and then being h1 and then being h2. So h0 by h1, the ratio of two successive decrements is same. That is one of the important result in undamped vibration. Okay, and h3 by h4, h4 by h5, this is after 5 cycles and so on, and this value is e power 2 pi zeta by 1 minus zeta square. So each of this value is called logarithmic or successive decrement or successive decrement, each of this value. Okay, but what we are given is h0 by h5 is 0.25. Now remember that when h0 by h1 is same as h1 by h2, so if I happen to write h0 by h5, this is obviously h0 by h1 into h1 by h2 into h2 by h3 into h3 by h4 into h4 by h5. When each of this is same as this, so finally this becomes h0 by h1 whole power 5. Now we are asked h0 by h5 is given as 0.25. It decreases to 0.25. That means the amplitude h5 by h0 is 0.25. So this is 1 by 0.25 and h0 by h1 whole power 5. So 1 by 0.25 is 4, and if I take 1/5 root of this, I get h0 by h1. So this value is my successive decrement, and this comes out to be 1.32. 1.3195. So the answer for 48 bit is B. Okay, successive decrement. Now I need to find out question number 49. Okay, so because I know the successive decrement, which is h0 by h1, and formula for h0 by is this, so 1.32 is e power 2 j by 1 minus zeta square. So if I take ln on both sides, so I can get the damping ratio zeta. Once I get the damping ratio, so this is, you have to just do some calculation, ln and divide by 2 pi and then take square root on both sides. So this value zeta, if you calculate using a calculator, this comes out 0.04408. So once I know the damping ratio, there is an important relation between damping coefficient, damping ratio, and this is one of the important relations. C is equal to 2 zeta m omega n. Now C is something which I want, damping coefficient. Zeta I came to know from the decrement value. Mass is given 2.5. Omega n is natural frequency, which is k by n. So this is root k by m. K is 3 Newton per mm, so 10 power minus 3. M is 2.5. So this value, if I calculate, this comes out to be 7.65 Newton second per meter. So 7.65, I mean, if you just calculate, so the answer for the 49th is B. So both the answers are B, 48th and 49th. Thank you.